are the three main properties of logs that we're going to go over. Product property says basically we were looking for multiplication. That's what product means. What's on the left side for each one of these are called condensed. These are in the condensed form. The right side of the equal sign, these are in expanded form. So if we are expanding with the product property, we're going to use addition. When we're expanding with the quotient property or division, when in the condensed version there was division, when we expand it, we're going to use subtraction. And then the power property says that if we've got an exponent going on like this exponent of n, then we can rewrite that with it in front of the log and it means the same thing. So have these available. We're going to reference each of these properties with several examples. The first thing we're going to do is we're going to apply these to real number examples. So if I know what log base 2 of 3 is, and I know what log base 2 of 7 is, I can find log base 2 of 3/7, because 3/7 is the quotient property. 3/7 is 3 divided by 7. So I could expand this and say that log base 2 of 3/7 is the same thing as log base 2 of 3 minus, because the quotient property is subtraction, log base 2 of 7. And I know log base 2 of 3 is 1.585 and log base 2 of 7 is 2.807. And when I subtract those, I get about negative 1.222. The next one's not as obvious, but log base 2 of 21 is the product property because 21 is the same thing as 3 times 7. So we have log base 2 of 3 times 7. So using the product property, that's log base 2 of 3 plus log base 2 of 7. Log base 2 of 3 is 1.585 plus log base 2 of 7 is 2.807. And when I add those together, I get 4.392. And then last example, 49, we can do two different ways. I could write 49 using 7 times 7, or the product property, or I could write it 49 as 7 squared, or the power property. The power property says that I can rewrite log base 2 of 7 squared as 2 times log base 2 of 7. So 2 times log base 2 of 7 is 5.614. And the reason this is useful to us is I can't just type into my calculator log base 2 of 49. There's a common log on your calculator and there's a natural log button on your calculator, but there is not a button with a base of 2. And so I needed to use this information that was given in order to calculate log base 2 of 49. And again, log base 2 of 49, we could have used the product property on that one. I could have said log base 2 of 49 is the same thing as log base 2 of 7 times 7. And using the product property, then I would have done log base 2 of 7 plus log base 2 of 7, or 2.807. I ran out of room there. 2.807 plus 2.807, which is still 5.614. So I could have done that either way using those original two logs that we already had evaluated. How these properties are more commonly used, though, is not just to evaluate a log, but just in general to be able to expand and condense when we've got variables involved also. So for this first example, we have log base 6 of 3 times x to the 4th power. So we have two properties going on here. We've got the product property and the power property because we have the 4th power there. So when I expand this, I'm going to have two logs, one for the 3 and one for the x. Both logs need to have a base of 6. So one for the 3, one for the x. And then because it's the product property, they're going to be connected by addition. And the power property says that because x is being raised to the 4th power, I can write the 4 in front of the log with the x. So this was the condensed way to write this. This is the expanded way to write that. And they mean the same thing. So the next example, we've got 3 ln's that we're going to write. We're going to need an ln for the 5, an ln for the 12, and an ln for the x. No power property going on here, but we do have both quotient and product. So 5 divided by 12x, so we're going to subtract. And the 12 and the x are being multiplied, so we could write our answer like this. Product property says we need a plus sign there. But more commonly, we would write our answer like this: ln of 5 minus ln of 12 minus ln of x. And the reason, again, we're subtracting that ln of x is because it is also in the denominator. It's also being divided by the 5. And so that's the quotient property still. One more example. Again, we're going to need 3 ln's, one for the 5, one for the x, and one for the y. This time we have all 3 properties going on here. The 5 and the x are connected by multiplication. So when we expand that, we use a plus sign. The x has an exponent. That's the power property. Anytime there's an exponent, it can be written in front. And then we're dividing by y. That's the quotient property, so we need a subtraction sign. So here's the expanded version. Next, we're going to do the opposite. These are all written in the expanded version, and we're going to condense it. So the first example, we've got log base 8 and log base 8. If those didn't match, we would not be able to condense it, but they do. So we're going to condense it to 1 log base 8. And I have subtraction here, so that's the quotient property. So x divided by y to the 5th power, because when there's a number in front, that's the power property at play. Next example, we've got log base 6, log base 6, log base 6, and we're going to rewrite it as 1 log base 6. First, we have the product property, so we're going to multiply the x and the y. And another plus sign, product property again, so we're also going to multiply by the z. So our answer is log base 6 of x, y, z. Whenever we write the condensed version, you should not have plus signs or minus signs. The next example, we have 2 log base 2's that we're going to condense into 1. We have subtraction, which means quotient property. A number in front means that's the exponent, so we have 3 to the 3rd power and 7 to the 12th power. 3 to the 3rd power, I can rewrite that as 27. The 7 to the 12th power is a very, very, very large number, so I'm just going to leave that 7 to the 12th power. And then the last example like that, we've got 3 log base 3's, but we're going to condense it down to 1. I've got quotient property, quotient property. So the only thing in the numerator is the a. And then I've got b squared in the denominator and c cubed in the denominator. The last thing we're going to talk about is the change of base formula. This is the last property we're going to cover. So we talked about how you cannot just type log base 3 of 8 into your calculator because there is no log base 3 on your calculator. What the change of base formula does is it says if you use either the common log or the natural log, you can calculate log base 3 of 8 by doing log of 8 divided by log of 3 on your calculator, or you can do ln of 8 divided by ln of 3 on your calculator. That's the change of base formula. So previously we were not able to calculate this, but using the change of base formula we can. Because if you were trying to do this by hand, the base is 3, and we want to know, basically we're trying to find the exponent that gives us an answer of 8. Well, we know 3 squared is 9, so the exponent must be less than 2, but we don't know exactly what it is. But using the calculator, let's see, log 3 divided by log 8, we get 1.893. We're going to do 3 decimals. And if you do ln of 8 divided by ln of 3, you get the same thing. So it doesn't matter whether you use the common log or the natural log, but this is a way to calculate logs that have a different base other than 10 or e. So one more example of that, log base 6 of 24. Again, you can't type it into your calculator just like that. But what you can do is you can type in log of 24 divided by log of 6. Or you can type in ln of 24 divided by ln of 6. And we get about 1.774. Or 6 to the 1.774 power equals 24.